So rather than expanding something like x plus y to the fifth by hand, we are going to use the binomial theorem. This is going to look complicated, I know that. But this is going to look complicated, I said, but it is so much simpler than doing the whole thing out by hand. It saves us a lot of time. Once we've done this, once you get the math, once you've done the binomial theorem, I'll teach you a shortcut that saves you a little time off of that. However, I'm not going to teach you the shortcut before I taught you the math, right? So we're going to go through the binomial theorem a couple times, learning how to do the expansions and getting the terms. And then I'll show you a little shortcut that makes things a little quicker. So here is the theorem. In your book, by the way, and in a lot of other places, it'll be x plus, they'll use x and y. I used first term and second term, and f and s, to try and clarify that just a little. But you'll see x and y too. So if n is a positive integer, and you are raising a binomial, that is two terms that are added together, to the nth power, the expansion of that is, instead of doing the whole thing out and then combining all the like terms, you can skip right to the expansion by using this formula. I know the formula looks complicated. It's a bunch of patterns put together. Once you've seen it a couple times, you will be familiar with the patterns, and it'll start to look a little easier, okay? So, we are going to expand, this is number one on your papers, x plus 2y to the fifth power. So, x is my first term, that'll be f. 2y is my second term, that'll be s. 5 is my power, that's n. Okay, here we go. The first thing I do is my first term to my nth power. So the first thing is just x to the fifth. Now, for the second term, I'm going to need 5, that's my n, times my first term to the n minus 1 power times my second term. So 5 times x to the fourth times 2y.
Couldn't you just write it out loud and then do it that way and boil it
You mean at each step simplify? Sure. Yes, I don't. I go through and do each one and then simplify them all. But yeah, you totally could. All right, now the next thing is going to be n times n minus 1, so 5 times 4, over 1 times 2.
Are we going to have to remember this formula?
No. And then my first term to the n minus 2, so this is now to the third power, and my second term to the second power. Sorry, that's not as clear as 3. There we go. Oh, yeah, I should have warned you a little earlier. Don't write too big.
Oh, dang it.
And pen, so it doesn't know that.
Next, 5 times 4 times 3 over 1 times 2 times 3.
This is still the same line, right?
Yes.
Whoa. Okay.
And then my first
Slow
term
it down just a bit, please.
to the second
Okay,
power.
you don't have to be smart about it.
And then my second term to the third power.
Where are you? Oh, I see. You're on the 1, 2, 3 part.
Yes.
The first 1, 2, 3. Or no, where's the, oh, we already did the 1, 2. There. Sorry.
This is intense.
And then 5 times 4 times 3 times 2. 1 times 2
that's-
times 3 times 4.
Why is this not in the formula? Yes.
Oh, okay. I will tell you in just a minute, okay?
Oh my God.
Times my first term times 2y to the 4th. The reason it's not in the formula is how many terms are in your whole expansion depends on what n is.
Oh my gosh.
You have to do every
No.
5? You have to do 5 of them?
What if this is 20?
So 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5.
It would be 20 if you were raising to the 20th power. You would expect that to be really long, right?
Yeah.
There will always be n plus 1 terms. So the reason I put a dot, dot, dot here rather than showing all of them is I can't show all of them without knowing what n is. This is the general equation. But I will show you how to know what to do. There's only one term left, and that is, I squeeze it in here, my second term to the 5th power. Pause and let you write all that down, and then I'm going to show you the patterns in it that make it much simpler to see what's going on. I promise.
Ooh, I hate that. I always hate that. You have too much. Right.
I'm done.
All right, so look. We've got the first term to the 5th power, and then to the 4th, and then to the 3rd, and then to the 2nd, and then to the 1st, and then not there at all. That is to the 0th power, right?
Right.
Yeah.
The second term, 0th power, or not there at all. And then the 1st power, 2nd power, 3rd power, 4th power, and 5th power. So the exponent of the first term keeps going down by 1, exponent of the second term keeps going up by 1. Also, and you could think of this first one as being 5 over 1, right? So this pattern, it starts by being n over 1. And then it's n times n minus 1 over 1 times 2. And then n minus 1, n minus 2, 1, 2, 3. And then 5, 4, 3, 2, 1, 2, 3, 4. And for the last one, it will be 5 times 4 times 3 times 2 times 1 over 1 times 2 times 3 times 4 times 5, so everything would cancel out. Yes, Jessica?
Is the top multiplier subtracted?
Multiplier. This is how you set it up. Now we're going to simplify. You can simplify. You can absolutely use your calculator. You will have to use your calculator. I do a lot of simplifying by hand and then going to the calculator, but you don't have to. The only thing I'm going to remind you of, if you have multiple things on the bottom of a fraction, you've got to put them in parentheses. And if you're ever raising a negative number to a power, you have to put that in parentheses. It's going to make a big difference. All right, so my first term is just x to the 5th. That doesn't need any simplifying. For my second term, I've got a 5 here, and then a 2 here. Multiplication is commutative, so we can change the order. So this second term is 10 times x to the 4th times y. Now this one, this is 20 over 2. So this part is 10, and then 2 squared is 4. So I've got 40, and then x to the 3rd, y squared. This one is 60 over 6. Yeah. Okay. So this is 10, but 2 to the 3rd is 8. So now it's 80 x squared y cubed. And now, well, these all cancel out. So this part is 5, and now we've got 2 to the 4th is 16. So this is 80 again, x times y to the 4th. And then the last one, the only thing to do here is raise 2 to the 5th, so it's 32 times y to the 5th. That's it. That's the full expansion. And
Oh boy.
And I know that that took a long time. But it still takes less time than doing the whole thing out by hand, right?
How do you do it by hand?
You remember how I did the warm-up?
Foil.
So first I foiled the first two, and then I multiplied everything I got by those same two terms again, and combined my like terms. And then I would do it again.
You would have to do that 5 times.
Yeah.
We
Which you
just doing this
completely
five
can
times.
do.
Yeah.
Yeah.
Okay. What did you say?
You completely can do it. I wouldn't want to. Well, I take that back. I would want to. That's the kind of thing that sounds fun to me. But you probably wouldn't.
No. I don't think there's any.
Okay. Now, for any individual term of the binomial expansion, of a binomial expansion, this is how you find the coefficient. So if you only want to find one term, like if I wanted to know what the fourth term was here, and I didn't care about any of the others, I could do the entire thing and then find the fourth term. Or if I use the formula, I can go straight to the fourth term. This is the formula we're going to use. I need to show you something.
That doesn't look like it.
All right, if I were asking for the fourth term of this expansion, what's the power of y in the fourth term? 3. So r is basically the power of your second exponent, and that starts at 0. So the value of r is always going to be 1 less than which term you're looking for, because it starts at 0. So, to find the fourth term of 5a plus 2b to the 6th power, n is always the exponent, so n will be 6. And r is 1 less than what you're looking for, so r will be 3. And we're just going to plug into this formula. N factorial, so 6 factorial, over 3 factorial. 6 minus 3 is also 3. 3, so that's 3 factorial again. Times your first term to the n minus r, so that's 3. And your second term to the r, which is also 3.
I'm super confused as to what we're
Next week's
doing.
our last week,
We are finding, if you multiplied 5a plus 2b by itself several times, right?
It's the second one, right?
It's the second problem, yes.
Okay, that just confused me.
Okay, we're on the second problem.
Next.
Now this, you can do in your calculator.
So the
Just-
other one's done.
What?
The other one's
The other one's done, yeah. There are no like terms, there's nothing to simplify, there's nothing to combine, it's done.
Where's the factorial in the calculator?
I'm about to tell you. So you can absolutely do this in the calculator. Let me urge you one more time. You have to put parentheses or it's going to come out wrong. Math over to probability, and then it's number 4 to get factorial. I'm going to do it by hand because that's the sort of thing I enjoy, but you can totally do it in the calculator.
Where
I don't
again?
know that.
Math
Yeah.
over to perb,
I suck.
Okay.
and then it's number 4. All right, 6 times 5 times 4 times 3 times 2 times 1 over 3, 2, 1, 3, 2, 1.
We said you do it all one day.
This is 3 factorial, 3 factorial.
I don't mind.
And now
Factorial
this.
squared? Does that work?
Sure. For this one, those numbers aren't always the same,
No.
but yeah. Here, I've got to raise 5 to the 3rd power, so this will be 125 times a to the 3rd. And 2 to the 3rd power is 8.
Yeah,
B to the 3rd.
8.
Yes.
Good for you.
And then I like to cancel. 3 times 2 is 6. Oh, this kind of 20 times 125 times 8. And that all simplifies to, if I did it right, what'd you say?
20,000.
20,000. Good. 20,000 times a to the third times b to the third. And that's a lot simpler than doing out the whole thing and looking for the fourth term, right? Yeah.
What is 20,000?
The fourth term of the expansion of 5a plus 2b to the sixth.
Okay, so hold up. So if we want a shortcut, we do this one, right?
No, actually, that's not the shortcut yet.
Oh my gosh. Okay, so what is this one?
That's just finding a single term.
A single term?
Yeah. So some questions will say write out the expansion. That's find all the terms. And some will say just find this term. Now, technically, I had somebody ask about this. You could use this formula for each term in the expansion if you find it all easier. That's totally fine. That's the same thing as what the rule is. Okay.
Who comes up with this stuff?
Now, I know it's the end of a long day, especially those of you who had SOLs, so I'm going to teach you the shortcut slightly earlier than any of the other classes got it. You got that triangle I had you do after the quiz?
Yeah.
Take it out.
I never got it.
Yeah.
Look at it. I'll give it to you.
By the way, if you don't have one, I don't have any filled out, so you could look on with somebody else. You can find it online. It's the Pascal's triangle. That's all it is. You can fill it out yourself. I'll tell you how.
Which one?
You will be able to use this on Monday's quiz and Wednesday's test. I will give you one. Let me go through this first. And then-
Look at how fast I'm going.
Oh yeah, it's on my desk. Yes, I'll get you one.
All right, give it to you.
All right, so for this problem, this is number 3 on the back. We're not going to use the binomial theorem. We're going to use the shortcut. So here's the thing about the shortcut. Well, it's a bit of a shortcut. We can't, so let me go back to number 1 and show you something. We can't get rid of all of the calculation we need to do. We can't do anything about the fact that these 2's need to get raised to their powers. But this stuff we can get rid of, or this stuff we can shortcut over. Because it turns out that what these come out to be, the coefficients here are 1, 5, 10, 10, 5, 1, which is exactly what you will find in the 6th row of your Pascal's triangle, or 5th if you start counting at 0, right? The one that starts 1, 5 goes exactly 1, 5, 10, 10, 5, 1.
This thing's bigger than what this picture shows.
It goes.
This one, just let me. Didn't look the same.
It can go on forever. But I couldn't give you a paper that went on forever. All right, so in order to do this, what we are going to do is find the, if you start counting at 0, then the 6th row, but I don't worry about that. I actually just look for, if I know I want to raise the 6th power, I look for the row that starts 1, 6. Okay? So the row that starts 1, 6, can you read me the numbers from that row?
1, 6, 15, 20, 15, 16.
Okay, those are the numbers that I'm going to use as those coefficients. We're still going to have to deal with the 2 getting raised to various different exponents and the -3 getting raised to various different exponents. What? Probably. But it will make it a lot quicker. So, my first coefficient will be 1. I don't really need to write that. Times my first term, 2p, to the nth power, 6. So far we haven't saved any time yet. We will.
So are we still using the formula?
No. Sorry, this is still up there because originally I was going to do this one using the formula. Now my second term will have a coefficient of 6. And then my first term to the 5th my second term to the first. Be careful, when you've got a minus sign in here, basically my first term will be 2p, and my second term will be negative 3q. So I've done this, I've done this. Now I've got 15. My first term, power is going down again, so now it's the fourth. Second term, power is going up, so now it's to the second.
Oh.
So do they have to add up to 6?
Yes, the exponents always add up to n, which makes life a little easier. You can kind of check yourself as you're going. My next coefficient is going to be 20. Then first term is now to the third power. Second term is also to the third power. Then 15, first term to the second power, second term to the fourth. There's only 2 more terms left, I promise. Woo! Then 6. First term is now at the first power, negative 3q. My second term is now at the fifth power.
And you're done. Just write the other one down.
Hmm?
Just write the other one down, then you're done.
And the last one has a coefficient of 1. I don't need to write that down. And then negative 3q to the sixth. We got to clean it up, but the cleaning it up is also a little faster. Don't clap until I'm cleaned up. No.
Do we have to do that?
Yes, we have to clean it up. We have to clean it up. This is not our final answer. That's messy.
It's equivalent to your final answer.
Well, so is the first. So's the problem. But
Oh.
that is, of course, they're equivalent to each other, but that doesn't mean you never have to transform them into another form. You don't have to find it funny. I'm just saying you have to transform it. Yeah, you have to transform it into a different form. All right. Let's clean this up. I'm going to need a calculator friend. Thank you. 2 to the 6.
Not even on. Hold on.
64.
Yeah.
That's not quick, that was. Wow.
This was actually much quicker.
now.
Please
I don't know if I
applaud.
have any-
Yes, thank you. Thank you. All right, I feel that. One last thing, which is, I'm glad you absorbed the American sense of humor. One last thing, which is finding a single term using Pascal's triangle. Okay?
Could you move to the right, please?
My right or your right?
That doesn't really matter.
So we are going to we're going to do example 4 just as soon as Cody's done.
Hold on.
So
There's another one.
this one, you.
So many formulas.
This one, this is the formula you've already used. You can use this, or I'm going to show you how to do it using Pascal's triangle, okay? So, if using Pascal's triangle, we're raising to the sixth, we're raising the sixth power. The line that starts with 6. Can you give me the first 3 terms from that?
15.
Okay. So the third term in the expansion of that whole thing would have a coefficient of 15, right? That's, by the way, this.
Oh, wow.
Yeah, it really is saving time. Now, to find out what the exponents are, you can either go back to n and r. I just basically count forward. Like if it's the third term, I'm going to start with a to the 6th, then a to the 5th, then a to the 4th, right? So this will be a to the 4th, and since my exponents have to add up to 6, that power is to the 2nd. Once again, you can totally put this in the calculator, but you have to put parentheses around it. This whole thing comes out to just 12. So 180 a to the 4th. exact tool line?
Okay, how do you,
Goes to
use
1,000
times it?
Yeah, 15 times, and then you can put this in the calculator. Use your parentheses.
Okay.